So in this video we'll see algorithm and flowchart. An algorithm, it is a step-by-step procedure to solve a given problem. A sequential solution of any problem that is written in natural language. Using the algorithm, the programmer then writes the actual program. The main use of algorithm is to help us to translate English language into the C code. It is an outline or basic structure of or logic of the program. The characteristics of algorithms are each and every instruction must be precise and unambiguous. Each instruction execution time should be finite. There should be a termination condition. It has to accept 0 or more inputs and produce compulsory an output. It can accept any type of input and produce a corresponding output. The general way of writing the algorithms includes name of the algorithm must be specified, beginning of the algorithm must be specified as a start, input and output description may be included, step number has to be included for identification. Each step may have explanatory note provided within the square bracket followed by operation. Then completion of a program must be specified as end or stop. Now we'll see with an example to write an algorithm to add two numbers. So here the algorithm name is addition of two numbers. Inputs are two numbers A and B. Output is the sum of the two numbers. Step 1 start. Step 2 input two numbers, that is read A and B. Step 3 compute its addition, that is sum is equal to A plus B. And the step 4 is print the sum. And step 5 is stop. Now we'll see another example to compute simple interest. So here the algorithm name is to find the simple interest. Inputs are PTR and output is SI, that is simple interest. So step 1 is the start, step 2 is the input principal P, time T and rate R. Then read PTR values. Step 3, that is compute simple interest by the formula SI is equal to PTR divided by 100. Step 4 is display SI. Step 5 is stop. So now we'll see the flowcharts. A flowchart is a pictorial or graphical representation of an algorithm or a program. It consists of a sequence of instructions that are carried out in an algorithm. The shapes represent operations. Arrow represent the sequence in which these operations are carried out. It is mainly used to help the programmer to understand the logic of the program or the flow of the program. So these are the following notations used in a flowchart. The first shape indicates start and stop. So the meaning of this shape is to denote start and stop of the flowchart. So the next shape is the parallelogram. So this indicates input and output operations, which is used to read input and output, display output. So the next is the rectangle. So rectangle indicates processing or computations used to include instructions or processing statements. And the next shape is a rhombus, so which indicates the decision or a condition. To include a decision making statements, a rhombus is used. And the next shape is the connector. So to join a different flowchart or flow lines, so this pictorial representation is used. And the next shape is hexagon, so which is used for repetition or loops or whenever we use looping statements. So this shape is used to indicate the repetition or loops. Then the next shape is the functions. So to include functions in a program, the name of the function should be enclosed within this figure. Then the next shape shows the control flow lines. So here the arrows denoting the flow of a control in the flow chart. And the next shape is the comment box. So for including the comments and the definition or explanation, so this shape is used. Now we'll see with the examples. So this following flowchart which shows the computations of area of a rectangle. So here at the left hand side we can see the algorithm, and the right hand side we can see the flowchart. And the start of the program is indicated with this shape. Then parallelogram used to read input and output. So here input is length and breadth, and the computation, that is rectangle, which is used to indicate the instructions. So compute the area. So area is equal to length into breadth, and the parallelogram, which is used to display the output as the area, and the last shape, that is indicate to stop the process.